Assalamu alaikum. My name is Bisma Sajid and I am from BS Biotechnology. Today my topic is about redox potential, but before that I would like to tell you that electrochemistry is the branch of chemistry that deals with the relationship between electricity and chemical reactions. It involves oxidation and reduction reactions, which are commonly known as redox reactions. Redox reactions either takes place at spontaneous movement and produce electricity, or electricity is used to drive non-spontaneous reactions. So what are spontaneous reactions? Because they are all the part of electrochemistry and electrochemical reactions. So spontaneous reactions are those which takes place on their own without any external agent, and non-spontaneous reactions are those which takes place in the presence of an external agent. And before we are going to start that, redox potential is basically oxidation and reduction of the chemical ions and atoms which are acquiring electrons from losing or gaining electrons. Redox potential is measured in volts and millivolts, which are the scientific units of redox potential. So what is oxidation? Oxidation is defined as addition of oxygen and removal of hydrogen during a chemical reaction. Let us explain it by what the oxidation is: loss of electrons by an atom or an ion. For example, if one iron atom will lose its electron, the other atom of iron will gain the electron, which is basically the electrochemical process. Oxidizing agents are substances which increase the oxidation number of an atom or ion. So the reduced agent will be oxidized and vice versa. What is an oxidizing agent? The oxidizing agent is the species that oxidizes a substance by taking electrons from it. The substance, atom or ion which is reduced itself by gaining electrons is also called oxidizing agent. Non-metals are basically oxidizing agents because they accept electrons and they become more electronegative atoms. Oxidation therefore results in increase of the oxidation number of an atom or ion. Now explain what is reduction. Reduction is the process of gain of electrons from an atom or ion. So it is defined as addition of hydrogen or removal of oxygen during a chemical reaction. Both oxidation and reduction takes place simultaneously in a reaction. So we can say that where there is oxidation, there is reduction. Reduction is the gain of electrons by an atom or ion. For example, if one chlorine atom will gain 2 electrons, then there will be 2 chlorine atoms in further reaction. What are reducing agents? Reducing agents are substances which decrease the oxidation number of an atom or ion. So it is a species that reduces a substance by donating electrons to it. The substance, atom or ions which is oxidized by losing electrons is also called reducing agent. We can have two definitions of reducing agents and oxidizing agents. Almost all metals are good reducing agents because they have the tendency to lose electrons. So if we are going to summarize this, so oxidation is losing electrons in a chemical reaction, whereas reduction is gaining electrons in a chemical reaction. And reducing agent is a substance that oxidizes itself and reduces the other. And oxidizing agent is a substance that reduces itself and oxidizes the others. As we are gonna say that the galvanic cell is the construction of is also the Daniel cell is the construction of galvanic cell, and the galvanic cell are working under electrochemical series chemical reactions. So here is a battery, and it is known as a basic Daniel cell. The left half cell consists of an electrode of zinc metal dipped in 1 molar solution of zinc sulfate, and the other half cell is a copper sulfate electrode dipped in 1 molar solution of copper sulfate. Salt bridge, which is the U-shaped glass tube, it is consisting of a saturated solution of strong electrolyte supported in a jelly-type material. The ends of the tube are sealed with a porous material which is made up of glass wool. The function of the salt bridge is to keep the solution of two half cells neutral by providing a pathway for migration of ions. So basically the zinc ions will move from salt bridge to the other vessel which consists copper sulfate ions. So zinc zinc will also have 2 electrons and copper will also have 2 electrons which are showing the signs of positive. Redox potential: if an electrical current, a flow of electron is applied in the opposite direction, whether some of the electrons are on positive direction or in negative direction, the strength of the electron activity or flow of electrons in the reduction reaction can be measured. That the electrons and the reduction and oxidation potential will be also measured if they are placed on opposite directions. The potential is measured at the point where there is no net flow of electrons. Basically the electron potential is measured where there is no net flow of electrons. The electrons are at zero state or electrons are stopped moving. Redox: just as we measure the activity of hydrogen ion, a proton, by pH with the pH scale which determines the acidic or basic saturation of a solution. So effect of O2 on redox potential. EH, which is used to determine the electron potential, is of natural lakes and streams, is relatively insensitive to changes in dissolved oxygen concentration. Except under very low oxygen concentrations, there is an average of every concentration, that is, it is less than 0.1 milligram of oxygen per liter. With depletion of O2, EH decreases greatly to 0 to 200 millivolt. The depletion of O2 will decreases the electron potential greatly from 0 to 200 millivolts. Effect of pH on redox potential. EH is sensitive to charges in pH, so O2 will have 4 electrons and we will further add 4 hydrogen, so it will give 2 water molecules. Measurement of redox potential. It is a standardized against the redox reaction of hydrogen with, that is, at H2 will gives us 2 hydrogen ions and plus 2 electrons will be separated from it. A hydrogen electrode is created by bubbling of H2 gas at 1 atmosphere of pressure over a platinum plate or wire. The redox potential standardized against the hydrogen electrode is termed the EH. As we have seen in the previous slide, the EH is the electron potential, and the redox potential standardized against the hydrogen electron, which is also termed as EH. EH of natural lakes and streams ranges from 500 to 600 millivolts. EH of distilled water is at pH 7, which should be 812 millivolts. So there is a range of distilled water at pH 7 which is neutral at 7. It should be 812 millivolts. Redox potential of natural lakes and streams ranges from 500 to 600 millivolts. Millivolts is the scientific unit for measuring the potential. A decrease of 1 pH unit is accompanied by the increase in EH of 58 millivolts. EH is frequently adjusted. Like everything has a frequent range. By adding 58 millivolts for every pH unit on basic side of neutrality, there is acidic solutions and there is basic and neutral solutions. Neutrals is the between of acidic and basic, and subtracting 58 millivolts for every pH unit on the acidic side of neutrality, or E7. Vertical profiles of EH in lakes. In well oxygenated lakes where the amount of oxygen is greater than hydrogen, there is little change in EH, while in depth As we go further down, there is a change in the measurement of electrode potential. In anoxic waters of the hypominion of eutrophic lakes, EH drops sharply from 0 to 200 millivolts. So in anoxic waters, they are discovering that eutrophic lakes have drops it have dropped the electron potential sharply from 0 to 200 millivolts. EH may be negative in the sediments. In the sediments, the EH may be negative because in other lakes or in other water which is at pH scale, it will be positive in range. So what redox potential strongly affects the ionic forms of many atoms and molecules. Basically, redox potential is only for gaining and losing the electrons, because the word itself says that redox means red means reduction and ox means oxidation. So redox potential and are directly proportional to reduction and oxidation reactions. Ionic forms determine solubility or reactivity of many compounds or atoms. It determines the solubility of and reactivity. So how much the reaction or compound is soluble, or what is the reactivity of it towards the other elements and other compounds. Insoluble complexes affect availability of nutrients, especially phosphorus. So insoluble complexes affect availability of nutrients. Some nutrients are affected and some of them get complicated in the reactions, as well as phosphorus is one of them. Thank you so much.